Imagine a time before time. Imagine a place where nothing existed, not even space itself. This is the mind-boggling concept of the singularity, a point of infinite density and temperature from which our universe burst forth. It's hard to grasp, to even try and picture in our minds the idea that everything we know, everything we see, once resided in a speck smaller than an atom. But from this tiny point, our universe was born. The universe, as we know it, began with a bang. Not an explosion that ripped through space, but an expansion of space itself. This is the Big Bang. The Big Bang wasn't an explosion in the traditional sense. It wasn't something happening in space, but rather, the expansion of space itself. Imagine a tiny balloon suddenly inflating to an enormous size that's closer to the picture of the Big Bang. In an instant, the universe was born, and space began to expand rapidly in all directions. In the first fractions of a second, the universe was an inferno of unimaginable heat and energy. It was a chaotic soup of fundamental particles constantly colliding and annihilating each other. Yet within this chaos, the seeds of order were being sown. The universe began to cool as it expanded. As the universe cooled, energy began to coalesce into matter. This wasn't a simple process. For every particle of matter created, an equal amount of antimatter, its opposite, was also formed. When matter and antimatter meet, they annihilate each other in a burst of energy. Thankfully for us, there was a slight imbalance. For every billion pairs of matter and antimatter, there was one extra particle of matter. This tiny surplus is what makes up everything we see in the universe today. As the universe continued to cool, the remaining matter particles began to form the first elements. Protons and neutrons combined to create hydrogen and helium, the simplest and most abundant elements in the cosmos. For millions of years, the universe was a vast expanse of hydrogen and helium gas, still cooling from the Big Bang. But gravity was at work, pulling these gases together into denser and denser clouds. These clouds, enormous beyond our comprehension, became the nurseries of the first stars. Inside these clouds, gravity relentlessly compressed the gas, heating it to extreme temperatures. Finally, the pressure and heat became so intense that nuclear fusion ignited. Hydrogen atoms fused into helium, releasing tremendous amounts of energy. The first stars were born, massive and brilliant, illuminating the early universe. The first stars were not solitary wanderers. They formed in clusters, bound together by their mutual gravity. These clusters became the building blocks of galaxies, vast collections of stars, gas, and dust. Over billions of years, gravity drew these clusters together, forming larger and larger structures. The universe was no longer a uniform sea of gas. It was now dotted with islands of light, galaxies of all shapes and sizes. Some were spirals, with graceful arms of stars and gas. Others were ellipticals, smooth and round, containing mostly old stars. And still others were irregular, shaped by collisions and interactions with their neighbors. Section 6. The Unseen Hand, Dark Matter's Influence. As astronomers studied the rotation of galaxies, they noticed something strange. The stars in the outer regions were moving much faster than they should have been, given the visible matter in the galaxy. It was as if an invisible hand was holding these galaxies together, providing extra gravity. This invisible hand is dark matter, a mysterious substance that makes up the vast majority of the matter in the universe. We can't see it directly, but we can infer its presence from its gravitational effects. Dark matter played a crucial role in the formation of galaxies, providing the extra gravity needed to pull matter together and shape these grand structures. Section 7. A Universe in Motion, the Ever-Expanding Cosmos. In the 1920s, Edwin Hubble made a groundbreaking discovery. He observed that distant galaxies were moving away from us, and the farther away they were, the faster they were receding. This observation led to a profound realization: the universe is expanding. Imagine baking a loaf of raisin bread. As the bread rises, the raisins move farther apart from each other. Similarly, as the universe expands, the galaxies are carried along for the ride, moving farther apart from each other over time. Section 8. The Mystery of the Unknown, Dark Energy. For decades, astronomers believed that the expansion of the universe was gradually slowing down due to gravity. However, in the late 1990s, observations of distant supernovae revealed something astonishing. The expansion of the universe is accelerating. This discovery implies the existence of another mysterious component of the universe: dark energy. This enigmatic force seems to be counteracting gravity, pushing the universe apart at an ever-increasing rate. The nature of dark energy remains one of the biggest mysteries in modern cosmology. Section 9. An Everlasting Expansion? The discovery of the accelerating universe has profound implications for the fate of the cosmos. Will the expansion continue forever, or will it eventually slow down and reverse, leading to a big crunch? The answer depends on the balance between the inward pull of gravity and the outward push of dark energy. As we delve deeper into the mysteries of the universe, we uncover more questions than answers. The birth and evolution of the cosmos remain a source of endless fascination, pushing the boundaries of our understanding and inspiring us to explore the vast unknown.